This question, this is for year 11 technical drawing. The topic that we're going to look at is on CAMS, right? So before we actually start doing the question from the workbook, we are going to look at a brief introduction on this CAMS. So if you look at the CAMS, first of you know the parts of a CAM, right? A CAM has a shaft, it has a crank, right? That's the shaft here. This is called the shaft, the long one here. This is the crank, that's the follower, and this is the cam. So when you move the crank in a rotational direction, the cam is going to rotate, and because of the rotation of the cam, the follower is going to go up and down. So there are many types of followers, so we're going to look at a few today in this exercise. A knife edge follower, you can see this is the follower, this is the cam here, that's the shaft here in the middle one, it's rotating, so the follower is going to go up and down. So that's the knife edge follower. This is what we used to determine, right? Knife edge, because this is sharp like a knife. The second one, roller, because this is a circular in shape, so that's a roller follower. Then we have plate type follower and a spherical follower, right? So these are the four types, but at year 11 level we are only going to look at a knife edge follower. But you should, for theory part, you should know the other types of followers, but for the drawing part we are only going to look at knife edge follower. Right, let's look at some of the types of cams. The first one here is a wedge cam. A wedge cam will have a reciprocating action. This means the wedge cam is not going to rotate, but it's going to move backward and forward, and because of that movement the follower is going to go up and down. The disc cam is going to have a rotational movement, the follower is going to go up and down. A face cam, as you can see, this is like something like a cylinder, and on the face of the cylinder you have a cut there in the shape of a cam. So when the cylinder is rotating, the follower is going to go up and down depending on the shape of the cam. Now we have a cylindrical cam, right? So this is one of the cams that is going to give us a reciprocating action of the follower. So here the follower is not going to go up and down, but it is going to go forward and backwards, right? It's going to go forth and backwards. And the last one here is a end cam. This one is similar to what you say a face cam, but in the end cam it's cut on the surface of the cam. On the face cam it was cut on the face, but end cam is cut on the surface. So depending on the cut there, the follower is going to go up and down. Right, some of the definitions here. A working circle, that is the maximum distance from the center to the cam shaft or the highest point on the cam. Right, so when you draw the cam profile, you will see that you will have a bigger circle. So that bigger circle is called the working circle. Now dwell is the period of time during which the follower does not move. This is one of the motions, right? So the follower will not move, but the cam will continue to rotate. Remember that the cam is going to rotate, but the follower will remain stationary. So dwell we can also call at rest. That's another name for dwell. Now this is shown on the displacement diagram by a straight horizontal line, and on the cam the dwell is drawn by an arc, right? You can use the radius and draw an arc. Now time interval is the time it takes the cam to move the follower to the designed height. Rotation of the cam is either clockwise or counterclockwise, but when you're designing the actual cam profile you have to do the opposite of the rotation. This means if you're designing a cam that is clockwise, you have to draw a cam profile which will be drawn in an anti-clockwise direction. If you are doing a counterclockwise cam, then the actual cam profile will be drawn in clockwise direction. I'll be explaining this one later on, why it is done like this. Now base circle is the smallest circle that can be drawn to the cam profile. You can also refer to your textbook for further explanations on these notes. We have a trace point, so that's a reference point on the follower which will generate the pitch curve. So this is the roller follower, so there will be a point that will be touching the curve here, so that will be our trace point. And pitch curve is the curve generated by the trace point, so where that part of that circle or the roller follower touches, that becomes the pitch curve. Then the prime circle is the smaller circle that can be drawn from the center of the cam and tangent to the pitch curve. So the smallest height of the pitch curve will be on the prime circle. Then we have the lift or stroke, which is the maximum travel of the follower from its lowest point to the topmost position. Right, so let's look at some of the motions during its travel. One was dwell, we have already discussed that. So when you are doing dwell, it will be just a horizontal line like this, just a horizontal line. You can follow my laser there. Now if the follower moves with uniform velocity during its rise and fall, so this is uniform velocity, you are going to use one diagonal sloping line, but it has to be a straight line, right? That's what uniform velocity means. Now simple harmonic motion, this is how the curve of simple harmonic motion looks like. And to draw this curve, you'll need a semicircle here, right? So first of all, you'll bisect this height here, find the midpoint, you'll draw one semicircle, then you'll divide the semicircle into 6 equal parts, you'll take the points across, and from that you'll be able to get the simple harmonic motion. So I'll be explaining this one later on exercise 2. Now, uniform acceleration and retardation, this is similar to simple harmonic motion, but it is using a different method to draw, right? So here let's say 0 to 180 degrees for the uniform acceleration and retardation with maximum lift or stroke. So if you look at 0 to 180, we have 1, 2, 3, 4, 5 and 6 equal parts there, right? So horizontally we have 6 equal parts, we need to have 6 equal parts vertically also. So you'll divide that into 6, 1, 2, 1, 2, 3, 4, 5, 6. Now if you look at the midpoint from 0 to 180 is 90, right? So where that vertical divisions intersect on that 90 line, that's where we are going to use to draw the curve, right? So first of all, we'll draw a diagonal line 0 to 180. Then from here, that's the midpoint, that's our first point. The next point, the next 2 points that are below, you'll take it to 0 degrees. The next 2 points that are above, you'll take it to 180 degrees, right, on top there. So if I take this one across, the first line, this one, the second line, the third line is already there, this one will be the fourth line, this one will be the fifth line, and that's how you draw uniform acceleration and retardation. Now let's move on to the exercise here. Right, the question here says you have to design a cam to fulfill the conditions of the given data. You have to draw a straight line uniform velocity lift of 20 mm for 150 degrees, a dwell for 60 degrees with another uniform velocity for 90 degrees, and a lower dwell of 60 degrees. Right, so that is the question we are going to look at. So the first thing you're going to do, we are going to take it parallel to the center line. From the smallest circle that is drawn there, we are going to take one line out. Right. Next you're going to draw a vertical line there, little bit away from the circle that is there. right? So it says uniform velocity lift of 20. So on that line, the vertical line we have drawn, which is here, we are going to measure 20 mm. Right, on that we are going to measure 10 mm. You can take any distance, but we'll try to take it constant as 10 mm. You can mark it 12 times. Right, so once you mark 10 mm 12 times there, using the height of 20, you can make one rectangle. Right, you'll mark it 12 times here. That's the height of 20. From there, you'll make a rectangle, and all the divisions here, you're going to take it straight up, and you're going to label it 0, 30, 60, 90. Right, those are the angles. So each division there represents 30 degrees. Right, so we have already done that. 0 to 360 already labeled here. It says uniform velocity lift of 20 mm 450 degrees. Right, so how to draw that? From 0 till 150. The lift is 20 mm, so that's the maximum height, 20 mm. You'll mark a point on 150, and you just draw it with a straight diagonal line. That's how you draw a uniform velocity. Right, the next part of the question is a dual for 60 degrees. 60 degrees means from 150 to 210. Right, so dual will be just a horizontal straight line. Now next one is with another uniform velocity for 90 degrees and a lower dual of 60 degrees. So from 210 you are going to count 90 again. So that will be 240, 270, then 300. That's 90 degrees, right? 30, 30 and 30. That's 90. So uniform velocity, you know, it's a straight sloping line. And the last one is a lower dual of 60 degrees. So lower dual or upper dual will be just horizontal straight line. You can label this as your performance graph or displacement graph. So whenever you are designing a CAM, the first thing you are going to do is actually design the displacement curve or the performance graph of the CAM. And please try to follow the standard. You have to use 3 mm guidelines here for printing. Right, so from that performance graph, we are going to draw the CAM profile here. This is the place we are going to draw the CAM profile. So first thing you're going to do there is divide the circle into 12 equal parts. Right, you also know how to divide the circle. From there you take it to the center, then mark it up and down. You are going to do that from all the four corners of the center line. Put it here, take the distance, you'll mark it here and there. Then from 90 degrees to there, you'll mark it here and there. And from 0 degrees till there, you'll mark it on this place and that place. And after you have done that, you are going to join all the lines passing through the centers. Right, so if you have equally divided the circle, you'll see from here to there, they should fall on the same line. Now what we are saying, it's not stated here which direction we have to design the CAM. So we are going to assume that the cam is going to rotate in clockwise direction. Right, so if the cam is rotating in the clockwise direction, our design will be opposite to that. So this means we have to design according to the anti-clockwise, right? As you can see, the labeling is already here. So the rotation is clockwise, but the cam will be designed in anti-clockwise direction. So like 0, this will be 30, 60, 90 there. Then we'll have 120, 150. So plus 30 at every division. We are going to label it around the circle. Right, so 0 degrees or 360 degrees is same, because when you start with one point, the other point, the ending point will be same. It's a full rotation. Now how to get the cam from the performance graph? Can you see the points that I am marking here? At 30 I have this point, at 60 the point is here, 90 is here, 120 is there, from 150 till 210 will be on top there, then 240 here, 300 here, or 270 there, 300 here, 330 and 360. So you are going to take all those points horizontally across to the center line of the circle that is there. We'll draw it for the first half of the cam, then we'll look at the next part of the cam. Right? Just be mindful of your construction lines. I am using a little bit dark lines here so that the work is visible to you. Right, so this is 0, 30, 60, 90, 120 and 150, which will be also same for 180 and 210, right, because they lie on the same point. So that is what I am writing here. This is 30, 60, 90, 120. This one is 150 to 210. Now you put your compass on the center, go to 30 and draw one arc till 30. The 30 is here. We are going to do the same thing for all the points, right? From there, center to there, 60 to 60. Okay. The last one you have to draw it from 150 till 210, because all those are same points. Right, from here 0 to 30, transfer it on 30, 0 to 60 using a compass, draw arc till you reach 60, then from the center till 90 here, from the center to 120, and then from center to 150, 180 and 210, because these three lie on the same points, right? Now let's look at the other points. We have 240 is this one, then 270 is this one, and 300 to 360 is the last one, which is already drawn there. So you'll transfer those points now. Right, you can draw a few points at a time so that you're not confused about the number of lines you have drawn there. Right, so the first line there, that's for 300, 330 and 360. This line here, the line that is going this way, that's for 270, and the line that is going here will be for 240. Right, so you can do the same thing and look at the points for 270 and 240. right? So this is 210, then 240, 270. The line was here. From there I have drawn a circle till 270. Now 300, 330 and 360 is going to lie on this same circle here. 300, 330 and 360. Now all the points you have located here, you're going to join using freehand, and this is how your cave is going to look like, right? Now this part here is a dwell from 150 to 210. This is a horizontal line. So from you put your compass point here, take that radius and draw a circle or arc, and that's a dwell, right, from there till there. And another dwell is here, which is already drawn there on the circle. Okay, so this is how you draw a cam profile. This is a very simple exercise. Now let's move on to the second worksheet. Before you go to the second worksheet, let me explain about the clockwise and anti-clockwise. Okay, so if the cam is supposed to rotate clockwise, this means after 0 your next point should come 30. So it's only possible when our 30 is drawn on this side. So this is the reason we are drawing anti-clockwise. Okay, so when you rotate clockwise, after 0 will come 30, then 60, then 90. Okay, so if you are drawing an anti-clockwise cam, then 30 will be there, 60 will be there, 90 will be here. So when you rotate your cam in the anti-clockwise, 30 will come first. So this is the reason why we draw the cam, or why we design the cam in the opposite direction. Okay, I hope that is clear. The other two part here, you can just refer to your exercise book and make sketches of whatever the question is asking there. Right, let's look at exercise 2. Right, this one is the second question in your TD workbook based on CAMS. The question says, the first part of the question says, a displacement graph of a cam at uniform velocity. You are required to draw a cam which would give a uniform velocity rise fall of a knife edge follower, right? So here you can see the performance graph is already drawn. You just have to draw the cam. This is uniform velocity, which is a straight sloping line. When you see the word uniform velocity or UV, you should know it's a straight sloping line. So from 0 to 180 degrees, that's a uniform velocity of rise. From 180 to 360, that's a uniform velocity fall. So here you can label 0 degrees, 90 is there, so in between you can say 30, 60, 90, 120, 150, like that. So it will be like an addition of 30 degrees. Each division here represents 30 degrees. So first step here is to divide the circle into 12 equal parts. Label like 30, 60 degrees all around, like that till 360, and draw the lines passing through the center. Right, to divide the circle, you are going to put a compass point here. So you are going to do the same thing from all the 4 corners of the center line. Right, as you can see, I have already divided the circle into 12 equal parts. Since 0 is there, 90 degrees is there, this will be 30, 60, 120, like that. Right, I have joined all the points going to the center line. Now my next step is to transfer all the points from the performance graph onto this line. Then from there I'll be drawing the circles to the respective angles that is shown there, right? For example, 30 is this one, 60 there, 90 there, 120, 150 likewise. So if you look at 30 and 330, they fall in the same line. Likewise 60 and 300 is same line, 90 and 270 is same line, 120 and 240 is same line, then 150 and 210 is same line. So when I take lines from this side, I will be also taking that line together. So I take it parallel to that line there, go to the first point, make sure that 2 points are in a line, then you extend it across. Go to the next point, so in the similar manner I'm going to take all the points across. Right, in this case the last point is touching the outer circle there, so this means for 180 the point is going to lie on that circle. The first point here is for 30 and 330, next one is for 60 and 300, then this one is for 90 and 270, next is 120 and 240, then the last one is for 150 and 210. Right, so here I'm going to draw from this center, take it to 30 and 330, so I can just draw it like this. Since 30 is this side, 330 is that side. The starting point will be here, because when I extend this line across, I'm going to meet here. That's my starting point. The next is for 60 and 300, so 60 is there, 300 here, then 90 and 270, right, so likewise you're going to draw all the arcs. You can mark the points and draw a, or join all the points freehand and make it dark. Right, so when you make it dark, you're going to get something like this. Now let's look at the second part of that question. It says a displacement graph of a simple harmonic motion. Simple harmonic motion, it's also known as SHM. You are required to draw a CAM which would give a simple harmonic motion of a knife edge follower, right? So here the performance graph is already drawn for a simple harmonic motion. Now if you want to know how to draw the performance graph of a simple harmonic motion, I'm going to explain that first on the same question here. Then from there we're going to draw the CAMS profile. Right, so what I have actually done here is to explain you how to get simple harmonic motion. In case if this performance graph was not given, but you have to draw a curve which will give a simple harmonic motion. So first of all, whatever lift is given there, the maximum lift, you are going to bisect that length. From there you are going to draw a semicircle and divide the semicircle into 6 equal parts. Then you will take all the lines across, right? So now the starting point will be here, first line there, the horizontal and the vertical line where they meet, that's 1 point. The next line here, that's a 1 point. Simple, you can label this as 30, 60, 90, then 30 there, this will be also 30, right? In this manner you can draw the simple harmonic motion, right? First point, first line, second line here, second line there, third line, you can follow like that. The last one will be right on top, then you come down again. So that's how you draw simple harmonic motion curve, which is not required here because you already have a curve. But in case if the question asks you to draw a simple harmonic motion curve, then this is how you're going to do it. Right, so this part of the question you should be able to do it yourself. Just whatever we have done it here, you'll divide the circle into 12 equal parts. Label like 0, 30, 60, 90, all those here. Then you'll take all these points across. This will be similar to that one because this is 30, 60, this is 120, 150, then you have 180, 210, 240, 300, 330, right? So 30 and 330 will be same line, 60 and 300 will be same line, then 90 and 270 will be same line, just like what we have done it here. Same thing you're going to do it here, and you'll complete this exercise. Right, that's CAMS. For exercise 3, this is the third worksheet on CAMS, right? This one is uniform acceleration and retardation. When you see the word uniform acceleration and retardation, so this is how the curve is actually drawn. Like from 0 to 180 is uniform acceleration and retardation of full lift from 0 to 180. So what you have to do, like here, if I look at 0 to 180, I have 10, 20, 30, 40, 50, 60. Or I have 1, 2, 3, 4, 5, 6. 6 equal divisions, right? Now I'll find the midpoint 1, 2 and 3. So this is the middle line. Since I have 6 divisions this side, this means I have to also have 6 divisions on the midline. So 1, 2, 3, 4, 5, 6. Right? As you can see, the 6 divisions are going that side also. Why 6? Because from 0 to 180 we have 6 lines here, so we need to have 6 horizontal lines also, and these horizontal lines can be also used to draw the curve that side. Now the middle one is 90, half of 180 is 90. You just draw one diagonal from 0 to the top where 180 is. That's your midpoint. Now the point that is lying below there, this one and this one, you're going to join it to the 0. So the first line here, that's your point. Second line, that's a point. Now the point that is above, you're going to join it to that corner like this. So this one is going to give a point here, this one is going to give a point there. Same thing you're going to do it here, right? In case if you're asked to make a uniform acceleration and retardation curve, so that's how you draw it. To draw this, actually similar to what we have done in the previous worksheet, divide the circle, draw the lines, label 30, 60, then you take the points across. In this case 30 and 330 will be same, 60 and 300 will be same, just like what we have done previously, right? But in this case it's going to be different, right? Here if you look at this question, we have 0 there, 120 there, and we have many small divisions. So it's like 0 there, then we have 15, then we'll have 30, then we'll have 45, 60, 75, 90, 105 and 120. This means here one small division represents 15 degrees. So each interval here is 15 degrees. So in this case you are going to divide this circle into 24 equal parts. right? You already know how to divide the circle into 12 equal parts. So you're going to divide the circle into 24 equal parts. In case you don't know how to divide the circle into 24 equal parts, let me explain. First, you are going to divide the circle into okay. So as you can see, I have divided the circle into 12, but we need 24 because here each division is 15 degrees, so total is 24, so we need 24 here also. So in that case, what you will do, like, you simply just bisect this. Put your compass point at 0, draw an arc, same distance you put it at 30 degrees, right? And then from there, where the intersection is, you just join a line directly passing through the center. You have bisected this one, you bisect this one, is already bisected together. You do the same thing here, this one, then you go this side, and you will be able to bisect all and divide the circle into 24 equal parts. Then in this case, you have to take every point separately, because this is not a symmetrical performance graph, as you can see in this case here. Here this point and that point were same, but in this case no, the points are different. So you take 15, 30 like that, first half, get the curve, then you take the next set of points, right? You can try and solve these questions.